Hi all, so we're going to start in with chapter 3, and so you'll notice your homework problem set is coming from 3.2, and we're going to talk a lot about counting. Now, we're also going to we're going to add some vocabulary in about talking about lists. So you'll see that the first thing that we want to do is define what a list is. Make sure you've got yourself all ready for notes and that you're good to go. So a list is an ordered sequence of terms or elements. Now, sometimes when we talk about lists, is that we'll call them entries on a list. And what ordered means is that the list A, B is not the same as the list B, A, unlike if it was a set. And we denote lists with parentheses versus brackets like we would for a set. So here, for number 1, create a list of the outcomes of flipping a coin twice. So the first would be 2 heads, 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 which you can just write as H. Start my parentheses for my list, comma, heads, then tails, tails, then heads, and then 2 tails, comma, not comma, parentheses to end the list. Now, another piece of vocabulary, this right here, all of these entries are strings. And a string is basically a list without any commas in between the entries. So this would, for example, be a list of strings, just to add a little bit more vocabulary into this lesson. Now, a lot of these ideas are going to seem familiar. I'm going to go through the examples that we have here. But again, if this feels familiar, this is something you remember from previous years, feel free to just jump into the homework and refer back to the notes and the lecture as you need. So the next question will be, how many ways are there to flip a coin 4 times? So we could write out this list, just like we did here, but we can also use what's called the multiplication principle, which means we want to think about these 4 times you're flipping a coin as 4 separate events. And we sort of write them out like this, where we have spaces for each of them. 1, 2, 3, 4. And if we take the outcomes of each of these events separately and multiply them together, we will get the total number of outcomes. This is the multiplication principle. And so each of these 4 events only has 2 possible outcomes, heads or tails. So you put in the number of outcomes for each event, and multiplying that together, we end up with 16 different outcomes for flipping a coin 4 times. This works really well for sort of broad categories. Sometimes, however, I will say there's things like number 3, where it's how many ways there are to flip a coin 4 times and get equal number heads or tails. Now, you can come up with a complicated way to calculate this. Some of the things that I'm going to do is I'm just going to write out, oh, it's at equal numbers of heads and tails. That means that we're going to have 2 heads and 2 tails. And I'm just going to write out the different outcomes. We can have heads and then tails like this, or you could have it the other way. So there's 2 outcomes that kind of look like this. You could have them where it's heads, tails, and there's 2 ways to do that, because we could start with tails instead. Or they could have 1 in the center and then end differently. And again, there's 2 ways to do that, just where you're switching around which one starts heads or tails. So that means that there are 6 possible ways that this outcome could occur. Sometimes it's nice to be really sneaky and use formula and use tricky math, and then sometimes you can just plug things in. Place where you don't want to write things out by hand are where they get more complicated. A passcode is created by entering 2 numbers and then 2 letters. How many possible passcodes are there? So again, we're going to treat each of these symbols in the passcode as a separate event. Now, it's got 2 numbers, so we're going to think about there are the numbers that are entered 0 through 9. So that means that there are 10 possible outcomes for the numbers. We're going to have those 0 through 9 right there. And then for the letters, there are 26. And since there are no other stipulations, we can just do this and then multiply them all together to get our total number, which would be 67,600. Now, things will become more complicated as we add different parameters to this problem. So in number 5, it says a passcode is created by entering 2 numbers and 2 letters. Again, how many if we can't repeat any symbol? So we're still going to think about it as 4 outcomes, 4 events. Now, the first one isn't affected. It's still 10 because repetition only matters for the second one. So we can pick whatever we want in the first place. Let's say it's 7. Now for the next place, this is no longer 10 because you have to subtract away the one number that you used. So if I used 7, I can't use 7 again. I only have 9 possible outcomes that I can put in that space. Similarly here, we have 26 for the first letter, which is fine, but if I used D, for example, I can't have that as my second letter, so now I only have 25 options. This means that there are now only 58,500 passcodes. We can add another parameter here saying, okay, well, what about if we're only using even numbers and we're only using consonants for our letters? The even numbers would be 0, 2, 4, 6, and 8. And the consonants would be your 26 letters minus the list A, E, I, O, and U. So it doesn't say anything about repeating, so we don't have to worry about subtracting away the ones that we've already used. So here we have 5 possible and then 5. And for the letters, we have 21 options each, meaning that there are 11,025 different possible outcomes. Let me know if you have any questions about lists or calculating with the multiplication principle. Either set up a Zoom meeting or you can leave something in the comments and make sure to nominate any homework questions that you're stuck on. I'll talk to you later.